disturbances, steady state. What do I want? That was fast. This is the dangerous part of the class when I have 6 minutes. We'll understand now the business about integral action, guys. That's what I'm driving at. Okay, so that's not what I'm going to show you. I'm going to show you that putting integral action eliminates steady state offset for both disturbances and set point changes. So, remember, I'm designing GC. GC is my property. I specify what GC is doing. And GC, of course, affects both GCL, it's here and here, here and here in GCL, and GDICL, it's here. Okay? If I can design a controller we design a controller that results in GCL of 0 equals 1 and GDI CL of 0 equals 0. What would be the steady state offset for any set point or disturbance change? It's going to be 0 no matter to what value set point change and no matter to what value disturbance change. You see that? If I can design a controller that has these properties, then the error is going to be 0 because this bracket is 0 and this is 0 no matter what the new set point state value is and no matter what the new disturbance steady state value is. Okay. I'm affecting GC. Let's look first at GDICL. GDICL of 0 is GDI of 0, which doesn't have GC in it, over 1 plus GU of 0 times GC of 0. I'm designing GC. What property should GC have or 0 have for this to become 0? Hold on.
Really big blow up.
Both of you correct? Really big, blow up. I would like, if GC of 0 goes to infinity, this guy is 0. What would GC of 0, what would GC of S require to become infinity at S equals 0? To have an S in the denominator, right? What gives us S in the denominator in the transfer function? Integral action. The integral action does what? Puts that something 1 over tau is, right? Puts that S in the denominator. Integral action puts S in the denominator of GC of S, and therefore gives GC of 0 goes to infinity, and therefore GDI CL of 0 equals 0. So you can see why integral action eliminates steady state offset for disturbance change. Clear now? point changes, GCL of 0 is GQ of 0, GC of 0, over 1 plus GQ of 0, GC of 0. Divide numerator and denominator by GC of 0. Equals GQ of 0 over 1 over GC of 0 plus GQ of 0. Integral action makes GC of 0 go to infinity, or 1 over GC of 0 go to 0. Therefore, GCL of 0 goes to GQ of 0 over 0 plus GQ of 0, which is 1. That's why integral action eliminates steady state offset for both set point changes and disturbance changes. I know, new concepts, guys.
Class dismissed.
Yeah. I think I gave you enough new concepts for today. One, you can come and talk to me.
Oh yeah.